Hi guys, welcome to your last video lesson notes for the trimester. That's kind of weird, huh? All right, so we're doing compound inequalities today. Inequalities are your less than, greater than, less than or equal to, that sort of thing. And then this word compound, you have heard that before, like a compound sentence or a compound word. Compound words, if you can think, like butterfly is a compound word, and that's because the word butter is a word on its own, fly is a word on its own, and you can put them together to make a word. So that would be an example of a compound word. So compound inequalities, to go kind of on that same track, it's two inequalities put together, okay? So you can go ahead and write that, two inequalities put together. Okay. Now there are two main types of compound inequalities. The first type we're going to look at is or inequalities, and the second type will be and those will make more sense once we explore them. So we're going to first talk about type 1, which is or. And we would never call them type 1. I'm just trying to make your notes organized. So they're called or inequalities. All right, so let's just talk about this word or. This is kind of the best way I can translate it into real life. If your parents, maybe your parents like took away your cell phone or something, and in order to earn it back, they said, you need to you got to clean your room or do the dishes to get your phone back. You got to clean your room or do the dishes to get your phone back. So in order to get your phone back, you could clean your room and they'd give you your phone back. Or you could choose to do the dishes and they'd give you your phone back. Since they said the word or, they're not expecting you to do both. Does that make sense? So like you only have to do one of those options in order to make your parents happy, right? Clean your room or do the dishes. You don't have to do both because that magic word or tells you you just choose one and it's fine. Okay, so as long as you do one of the options, your parents will be happy. Keep that concept in mind when we do these next problems. Okay, so here's your first example of a compound inequality, and I'm actually going to show you, I think I want to show you the graph of it to start. So make a number line. And let's go from -4, I'm going to count by 2s, all the way to 6. Doesn't have to be exactly, but get some values on a number line. Okay, definitely want to show -2 and +4. Those are going to be our main points of interest. So let's say there was a closed circle at -2 pointing to the left. Okay, possible test question might be go ahead and write the inequality that the graph is representing. Okay, well, it's pointed to all the solutions, and there are many solutions for inequalities, right? So -4 would work, -1000 would work, and also -2 would work because it's a closed circle. So -2 or less. So the first part of that inequality would be x is less than or equal to -2. But in compound inequalities, you have two inequalities within the same statement. So on this number line, you kind of have another section of solutions. Okay, so there are some solutions here, -2 or lower. But then also we're going to go to +4, and we're going to put an open circle at +4, and we're going to point it to the right. See how you basically have two inequalities on the same graph? That's allowed. That's a compound inequality. So what it means is you have kind of two different solution areas. So just like how you could either clean your room or do the dishes. As long as you did one of them, it'd make your parents happy, right? So as long as your solution is in this little section or this little section, it makes the statement true. Now the key word is we got to put the word or in between our first little inequality and our second one. So let's write our second one. 4 is your main point of interest right here, right? And it's to the right of 4. So x, which are your possible solutions, are bigger, which means greater than 4. Notice I didn't put the or equal to, and that's because that's an open circle. Meaning 4 is not a solution, but anything greater than that would make the solution true. So let's talk about possible solutions to this, and keep in mind, clean your room or do the dishes. You don't have to do both since it says or, meaning it could be something over here or something over here, all right? So like -2 would be a solution because it's closed. -4 would be a solution. -15 would be a solution because it's to the left of -2. 4, would 4 be a solution in this case? No, because it has an open circle. 4.1 would be fine though. 4.01 would be fine because it's greater than 4. 5 would work, 6 would work, 1,000 would work because it's over there. Okay, so those are some possible solutions for that. All right, now let's go reverse order. I'm going to give you the compound inequality and then we'll practice graphing it. Okay, so here's your next one. X is greater than 10 or, and you have to write or to know what type it is, or x is less than 0. Okay, so I have to include these 2 points on there, 0 and 10. So you could count by 5s, 10s. I'm going to count by 5s. So I'm going to put 0 like right here, 5, 10, 15, -5. You just got to make sure you at least include those points of interest. Okay, so I just start with this little chunk first. So just pretend you're graphing this. X is greater than 10. So we go to 10, open or close circle. It's going to be open because it's not equal to. And greater is always to the right. Okay, now let's graph our second little part of the inequality, compound inequality. X is less than 0. So I go to 0, open or close circle, open. And since it's less, remember L, slanty L, less than, that's how I know how to read it. Less than 0 would be to the left of 0, okay? So 0 and 10 are not possible solutions here, but anything to the left of 0, so -1, -1,000,000, those would be possible solutions. Or you could have something higher than 10, so 10.05, okay? 11, 12, 1,000,000. Those would be possible solutions. So as long as it satisfies one of these inequalities, it'll make this statement true. Just how if you clean your room or do the dishes, it makes your parents happy. You don't have to do both. You just have to do at least one of them. Okay? Okay, so something you may have noticed. Notice how both of these graphs separate. That is the key characteristic of a compound inequality. So if I visually see this, I go, oh, that's going to be an or statement because I have solutions over here and solutions over here. So ors typically separate. So we're just going to make note of that. I'm just going to say or inequalities typically, because we never want to say always in math. Because there's always weird cases, you know, so typically separate. Oops, spelled separate wrong. S-E-P-A-R-A-T-E. So that's your keyword. They separate. Or inequalities typically will separate. So now that we've talked about graphing them, we're going to look into solving them. Okay, so we're going to solving or inequalities. Okay, So we just got done last week solving inequalities. And solving inequalities was just like solving equations. Get your variables to one side, get x by itself. The only weird thing, remember, the only weird thing is if you multiply or divide by negative, you had to switch the sign. And that's usually gonna happen, if it happens, it's gonna happen towards the end. So right here, I divided by -4, which means we had to switch the sign around. In this problem, we divided by positive, so we didn't have to switch the sign, we just dropped it down. Okay, so you're still gonna have to keep that in mind whenever you do inequality stuff. If you multiply or divide by negative, you gotta flip the sign around, okay? So let's look at how to solve a compound inequality for ORs. So here is, we'll call this number 3. So we have -3 times parentheses 2x plus 1 parentheses is less than -15. Or 1 minus x is greater than or equal to 5. So here's how I approach solving OR inequalities. Even though this is going to be like one thing smashed together, okay, we're going to get an answer like this. X is something compared to whatever, or X is something compared to whatever. Okay, we're going to get an answer that looks kind of like, you know, this or this. How I approach these is I think of them as two separate problems because they kind of are. So I'm going to solve this one down and get X is less than whatever. And then I'm going to solve this one and get X is greater than whatever, okay, or whatever that happens to be. So let's start with this dude. I'm going to start by looking at my left side of the inequality, and I see that there's some simplifying we can do, some distributive property. So we distribute the -3. -3 times 2x is -6x. -3 times 1 is -3. Drop down your less than, drop down your -15. Now I'm not going to do a bunch of examples on this because we should know how to solve this. So I suggest you actually pause the video right here and just push play when you want to check your answer for this one, okay? All right, next I'm going to add 3 to both sides. -6x is less than -12. -15 plus 3 is -12. And then I have one last move to do. I need to get rid of this coefficient. So I divide by -6. Since you divided by a negative, you needed to switch the sign around. So you would have x is greater than +2. So that is your answer for that part of the compound inequality. But we still have to solve this side, okay? Same thing, I suggest you pause the video, solve it real quick, and then check your answer, because I'm not going to do a lot of examples. Okay, so for this one, I want to get x by itself, so I'm going to cancel out this 1. Since it's +1, I subtract 1 on both sides. I'm left with -x, be careful to bring that negative sign down, is greater than or equal to 4. But I don't want a negative variable. No, no, no. So I'm going to divide by -1 because there's a secret 1 there. So the coefficient's -1. Divide by -1, and ruh-roh, I divided by a negative. I have to switch the symbol around. So I have x is less than or equal to -4. Okay, so we solved this one. We got x is greater than 2. We solved this one. We got x is less than or equal to -4. The only thing left to do is to bring down the word or. Or needs to go in the middle of these two, and here's your final answer. X is greater than 2, or x is less than or equal to -4. That's your full answer, okay? Now let's practice graphing just so we can practice that. I gotta at least include +2 and -4. I gotta fit that on my number line. So here's 0, 2, 4, -2. Okay, so you gotta make sure you include those two numbers at least. And since it's an or, we know that it should be separating, but obviously we'll double check it. So let's focus on just graphing this little chunk. X is greater than 2. We go to 2, since it's strictly greater and not equal, that means it's an open circle, and greater is always to the right. And then we'll go ahead and graph this inequality. X is less than or equal to -4. Since it can be equal, we have a solid dot there, closed circle, and less than is to the left. Okay, so the graph shows your solution area. So anything -4 this way of it would work, or anything to the right of 2 would work, would satisfy the inequality. Okay, so we're gonna do your practice problems a little bit different today. We're not done with notes. We are a third of the way done, okay? But this is gonna be a practice problem, okay? So I'm gonna write it down and then we're gonna continue taking notes. So it's your choice. If you wanna solve it now and then hit play and do the rest of the notes, that's fine. If you wanna do all your practice at the end, do what works best for you. So here's your practice question. 2x, oh, sorry, that's a -2x. Okay, -2x plus 9 is less than or equal to 1. Or 5x plus 10 is less than 10. So I'm putting a star next to this because that's your practice problem. You'll enter in your answer into the entry task. The answer, we won't do graphing in the entry task. We'll just focus on this. So you would literally type, like if this was what you're typing in entry task, you do x greater than 2, space, or space, x is less than or equal to -4. Okay, so anyways, this is your practice question, but we still have more notes to do. So this was just the first type. This is the or compound inequalities. The other type, we'll call it type 2, is and. Okay, so to connect this back to real life, we said or, how I want you to think about or is your parents telling you to get your phone back, you need to clean your room or wash the dishes. Okay, so you had kind of a choice there. You didn't have to do both. It was one or the other. As long as you did one of them, your parents were happy. If they were to not say the word or and actually say and, so if they said, in order for you to get your phone back, you have to clean your room and do the dishes, then that means that you have to do both, right? You can't just clean the room to get your phone back. You'd have to clean your room and do the dishes to get your phone back. Okay, so you have to do both things in order to make your parents happy. Okay, so now let's connect that to math. What are we on? Problem 5. So let me show you what a graph would be. So graphs of the or separate. Well, what's the opposite of separate? Connect. You're going to see that. So let's look at a number line here. I'm just going to count by, I'm going to start at -3. Just count by ones, see how far I get. Okay, so something like that. -3 to 2 or -3 to positive 3 is fine. Okay, so let's say there was an open circle at -2 and a closed circle at 1. And instead of separating, they actually connect. Let's think about what that means. So if I saw this graph, I would for sure know, I'd go, oh, that's a compound inequality, and it's an and statement because ors separate, ands connect. Okay, what that means is your possible solutions lie in between these two endpoints. Okay, so anything in this section would work. Okay, but if you have a number like 2 over here, it wouldn't work because it's not in the solution area. All right, so let's try and write this as a statement. Let's try and write the inequality as a statement. So let's just focus, let's go to the left part of it. -2 is definitely a point of interest here, right? X is what compared to -2? Which way is your arrow going here? It's to the right of -2. So since it's to the right of -2, we would say X is greater than -2. Notice I didn't put the line underneath because it's not filled in at -2. Okay. Now we would put the word and, because this is an and inequality. And you would go to your other point of interest. X compared to 1. Well, solutions are to the left of +1. It's to the left of 1, which means it's less than 1. X is less than 1. But on this one, it's a closed circle, so it can be equal to 1. So that would be my compound inequality here. X is greater than -2, and X is less than or equal to 1. Meaning numbers in between here satisfy both. Let's think of 0. Is 0 greater than -2? Yeah. Is 0 less than 1? Less than or equal to 1? Yeah. It has to satisfy both, okay? So if we plugged in a 2, a +2, 2 is greater than -2. Yeah. Is 2 less than 1? No. And in this case, because it's and, it has to satisfy both little chunks or else it's not a solution, okay? Whereas when it's or means like either or. As long as it's fine on one of them, you're cool. For and has to satisfy both. So it's this intersection piece. Any of the numbers in this intersection piece, the overlap would work, okay? So I'm going to give you a statement and we're going to graph it. So X is less than 5 and X is greater than or equal to 0. I challenge you to graph this on your own. Pause the video, graph it, check it. Okay, so as long as, sorry, this is terribly spaced, but as long as you have 0 and 5 in there, you're fine. Okay, you can put numbers in between. I know that this isn't super evenly spaced, but we'll pretend. Okay, so X is less than 5. So I'm gonna go to 5. I see that it should be an open circle. And since it's less than 5, I'm not gonna do the full arrow. I'm just gonna start heading that direction to show myself it needs to be to the left of 5. Because this says and, I'm not gonna do the full arrow because I know it's gonna have another end point somewhere. X is greater than or equal to 0. So I go to 0. Since it can be equal to 0, I do a closed circle, and greater means to the right. So anything in between these two endpoints right there would be a solution of this inequality, okay? So that's how you graph them. It takes practice, okay? You might look at this and go, huh? It just takes practice and then you'll pick it up, I promise, okay? So the main thing I want you to really connect in your head about and inequalities is they connect, okay? Or inequalities separate and inequalities typically connect. So we're gonna write that. And inequalities typically connect. Okay, now, and inequalities are a little bit more special than or inequalities. So we do need to make a little special note. We're going to write a sentence, okay? So pause it if I'm writing too fast. Because the solutions are answers, by the way. Because the solutions to an and inequality fall between two endpoints, comma, because the solutions to an and inequality fall between two endpoints, they are typically written in a condensed form. X is sandwiched between the endpoints. I know that's lots of words there, so feel free to pause the video. Pause it, and then once you get it written down, push play. So because our solutions fall between two endpoints, so they're in between these two instead of outside, then we actually don't really see it written with the word and a lot of the times. It's just implied. So we actually usually see it, I call it a sandwich. It's not a math word, but it's how I think of it in my head, because a sandwich has your piece of bread, and then your important stuff's in the middle, right? Just like how X right here is sandwiched between 0 and 5. So all the solutions are right here in the middle of those two endpoints. They're sandwiched between those two endpoints. So there's actually a different way we would write it. So let's go ahead and practice this. If we said X is greater than -1 and X is less than or equal to 10. Let's say that's our and inequality. We would actually write it in a different way. So I'm going to put a big arrow sign. I'm going to say 80% of the time you wouldn't see it written with the word and. Maybe even 90% of the time you wouldn't see it written with the word and. You would see X sandwiched between the two endpoints. So here's how you do it. You put X in the middle. Your two endpoints are -1 and +10. Put the lower number on the left. So in this case, that's -1. Put the larger number on the right. Okay. Kids have a hard time with the symbol that goes here. So I'm always going to recommend that you start with your comparison to the right. So right there, X is less than or equal to 10. So I'm just going to transfer over that symbol. This is the symbol that kids mess up on. They want to just put a greater than symbol, and that would be wrong. Look at it. Your alligator is chomping towards the X. It's still got to chomp towards the X. Okay? Okay. So one thing to notice is your symbols go in the same direction here. That's how you know it's an and statement. X is between those two. Okay? So what this says, you can say it two different ways. -1 is less than X, which is less than or equal to 10. You can also see that X has to be less than or equal to 10 and greater than -1, okay? Because the alligator's chomping towards the X, so the X is bigger than -1. Okay, so now let's talk about solving and inequalities. So most of the time, you're going to see it in this sandwiched version, all right? So like this. 2 is less than or equal to 2x plus 4, which is less than 10. So when you read something like this, you really need to pick out how many inequality symbols you see. Because when we're solving, something like this, there's only one inequality symbol, okay? But on this guy, there's 2 inequality symbols, and that should tell you, oh, this is a sandwich one. I have to figure out what X is sandwiched between. Your endpoints right now are not 2 and 10. And the reason why I know that is because X is not by itself right there. So you kind of have 3 columns. Instead of having 2 sides, you know, whatever you do to one side, you do to the other, you actually have 3 columns. Okay, so whatever you do to one column, you have to do to all columns. And in fact, we might want to write that over here. Whatever you do to one column, you have to do to all columns. And that's for and inequalities, because the and inequalities are the ones that have a sandwich. Okay, they got like 3 little chunks to it. The reason why we didn't have to follow that necessarily on the ors, like right here, when we subtracted 3, we didn't have to subtract 3 to this one because these were like kind of 2 separate problems shoved together at the end. Okay, so or inequalities you solve kind of separately, individually, and then you put them together at the end. But for and, it's one big problem together. So whatever I do to get X by itself here, I gotta do it to all 3 columns. So if I'm focusing where X is at, and X is in the middle column, typically it's gonna be in the middle column because it's sandwiched. So first number I get rid of is the 4. So I subtract 4, but whatever I do to one column, I have to do to all 3. So I gotta subtract it to the 10 and subtract it from the 2. 2 minus 4 is negative 2. Drop down your symbol. I'm left with 2x. Drop down your symbol. 10 minus 4 is 6. Is x isolated? No. So get x by itself. Well, since 2 is timesing by x, I'm going to do the opposite. I'm going to divide by 2. But whatever I do to one column, I have to do to all 3 columns. Negative 2 divided by 2 is negative 1. Drop down my symbol. By the way, you divided by a positive, so you don't need to flip the symbol here. Just drop it down. 2 divided by 2 cancels. I got 1x. It's less than, and then 2 divided by, or 6 divided by 2 is 3. Okay, so here's your final answer. X is sandwiched in between negative 1 and 3. So if we go to graph this, I need to make sure that negative 1 and positive 3 fit on my graph. Okay. We're going to have a point at negative 1 and a point at 3, and X is going to be sandwiched. So this is going to connect. So I just kind of, to do it quickly, I go, okay, at negative 1, it has the or equal to. So since there's an or equal to at negative 1, it's a solid dot. It's a closed circle at negative 1. But if you look at your 3, 3 doesn't have the or equal to, so it's going to be an open circle at 3. And then you connect them because it's a sandwich. It's an and statement. So X is anywhere between those 2 values, including negative 1. Okay? All right, so this next one, number 8, it's going to be a similar situation. Your X is in the middle, but you got to get it isolated, okay? So here you go. This is your practice question. You'll enter it into your entry task. 2 is greater than or equal to negative 3x minus 4, which is greater than or equal to negative 16. Definitely solve it. That's what you're going to be entering in on the entry task, and graph it because you need the practice. Okay, so that's your next practice question. All right, but we're not done. All right, keep pushing through. Keep pushing through. We're not done. Now we got to talk about a very important part of this, which is word problems. Word problems or phrases, whatever you want to call them. So we've done this before. This was in our first lesson, translating phrases like you can spend $20 at the most and writing it as an inequality. So we're going to do a couple of those because you are going to see those on your test. Here you go. Your weekly salary your weekly salary is more than $300, comma, but not more than $500. Okay, and we'll write the statement over here. Your weekly salary is more than $300, but not more than $500. Okay, so I see two values. Right away, I know that this is a compound inequality because I'm comparing it to two numbers, all right? X in this case would be my weekly salary, so how much money I make in a week. I make more than $300. So I'm already looking, kind of thinking, okay, X is more than 300, not more or equal to, it just said more than. So that's that part. But the second little piece here is, but not more. Not more means less. Not more means less. But it could also be equal, as long as it's not more than it, okay? So my salary is less than or equal to 500. Now here's what I need you to think about. If you were to plot these on a graph, here's 300, here's 500. Would your two dots here, would they separate or connect? Because I think that's the most helpful way to know if it's an and statement or an or statement. So you're making above 300, so you'd be going this way, but you're making less than or equal to 500. Because this connects, it's an and statement. And I'm going to kind of ask that for your and statements, you make a sandwich, okay? Meaning you put X in the middle, you put your lowest value on the left, your highest value on the right. And then you got to be really careful when you fill in your symbols. I always think it's easier to fill in this one first. X had to be below or equal to $500. And then it's so tempting to want to put greater than, but really X is greater than 300, which means 300 is less than X. A good way to check is your symbol should be going the same way, okay? So that's how you would write that. It takes practice. It does. Here's number 2. People typically complain about the weather when it is less than 50 degrees or when it's 90 degrees and higher. You know, and these are not like super scientific statements. I made them up, but I feel like it's probably pretty true. People complain when it's less than 50 degrees because they're like, oh, it's so cold outside. And then they also complain when it's 90 degrees or higher because they're like, oh, it's so stinking hot out, right? It's kind of true. So think about if you can already tell if this is going to be an or statement or an and statement, okay? And I'm very visual. So like for me, I draw a number line, I do. And I'm not saying you have to, I just think it's a good strategy to use. 50 and 90 are your main points here, right? But you need to think about, are they going to separate or connect in this situation? And we're talking about when people complain, okay? So if you want to use C for complain, you can totally do that. You don't have to use X every time. But when are people going to complain? They're going to complain when it's less than 50 degrees. Okay, so when it's below 50. And when it's 90 degrees, so equal to 90, and higher. Okay, now that's an or statement. So we have to separate it out with the word or. So we're going to start with this one. X is less than 50. Or X is greater than or equal to 90. Okay? It takes practice. It does. All right. I'm going to go ahead and make this your practice problem. You'll enter it into your entry task. Okay? Here you go. Megan watched more than 10 episodes of Riverdale, comma, but 20 at the most. Megan watched more than 10 episodes of Riverdale, but 20 at the most. So kind of go through the process. If you're visual like me, maybe make your number line and figure out, is it going to separate or connect? If it connects, you need to make sure you put it as a sandwich. If it separates, then it's an or statement and you put the word or. Okay? Okay, so that will be part of your entry task as well. The last little piece of this, I'm literally just going to write the word careful. These we're going to get into if it's possible to have no solution and infinite solution when we solve compound inequalities. Yeah, it's possible. It doesn't happen a lot, but it's possible. Okay, so here, ooh, I don't know why I'm going to renumber these because I'm weird. This would be 9. This would be 10. This is 11. Just so on the entry task, you know what. Okay, so this is 12, number 12. Let's say we had this inequality. X is less than 2 and X is greater or equal to 4. Now, this one isn't sandwiched, but let's just double check. So I'm going to draw this on a number line. I got 2 here, I got 4 here. So what this is saying is that X is less than 2 and X is greater or equal to 4. But it says the word and. If it separates like this, that's an or statement. That ain't gonna work. And it makes sense because is there a number? Can you think of a number that's less than 2 and also greater than 4? It doesn't work. Numbers less than 2 are not also greater than 4. It doesn't work. And number 3 doesn't work either. Some of you are like, well, 3's in the middle of them, but 3's not less than 2 and 3's not greater than 4. So 3 doesn't work for either of them. Any numbers over here would only work for this side and not both. Any numbers over here would work for this side and not both. Okay, and for and, it has to satisfy both. So what we would write here is no solution. Okay, doesn't happen often. I just want you to know that it exists. 13. X is less than 3. So start thinking of numbers less than 3. Or X is greater than 0. So let's look at this because I'm visual. 0 and 3 are my main points here. Okay. And let's just start graphing this. X is less than 3, so I'm going this way of 3. X is greater than 0. But is this going to connect? No, this says or. So I'm going to do this in 2 colors. So this one would be going, anything less than 3 would work. Anything greater than 0 would work. Because it's an or statement, it doesn't have to be the intersection of the 2. And statements are the intersections of the 2, okay? But or, it's just got to work for one of them. okay? You're either cleaning your room or doing the dishes. You don't have to do both, right? So think of a number. Let's check 4. Does 4 satisfy this statement? So look up here. 4 less than 3. No. So that side's no. But 4 is greater than 1. And since it's an or statement, it only has to work for one of them. Let's check the in-between section. Let's check 1. Is 1 less than 3? Yes. Is 1 greater than 0? Yes. So it doesn't have to work for both of them, but it does. So that's fine. And -1. -1 is less than 3. Is -1 greater than 0? No, but that's fine because it worked for this side, okay? So you know what that means? That means that all numbers are solutions for x. So you can write all real numbers or you can write infinite solutions. I'm going to write both. All real numbers. Another way to say that is infinite solutions. Infinite solutions. Okay, so either one of those means the same thing. Okay, so these don't happen a lot, and no, you're not going to see them on your test, but I just wanted you to be aware of them. Okay, so cool. That was our last lesson of the try. Woo. So just to recap, on your entry task, and what I want you to practice right now, if you haven't already, number 4, you need to practice. Number 8, you need to practice. And number 11, you need to practice. Okay? See ya on Zoom. Bye.